Welcome to this video on steam locomotives in Harz, covering their journey from mining pumps to tourism. We will explore the history, technology, and heritage of these magnificent machines. This video will focus on steam locomotives in Harz and their evolution from essential mining tools to a tourist attraction, delving into their history, mechanics, and cultural significance. A contemporary definition of a steam locomotive is a traction vehicle powered by steam generated in a boiler, often by burning coal. This energy is converted into mechanical motion for the driving wheels. The mining problem in the 17th and 18th centuries involved flooded underground mines. The solution was the steam pump. Thomas Newcomen introduced the first practical steam engine in 1712, where steam powered a piston to move the pump. Mining and coal were the cradle of the steam age. James Watt, a key figure in steam engine development, invented the centrifugal governor, or regulator, to automatically adjust the engine's speed. It reacted to RPM changes without human intervention, ensuring safe and stable industrial steam use. George Stephenson, a pioneer of steam railways, designed the rocket in 1829 for the Rainhill Trials competition. It ran on the Liverpool-Manchester Railway. The goal was to find the best locomotive for regular operation. Key technical innovations of the rocket included the multi-tube boiler for a larger heating surface and the blast pipe to evacuate steam into the chimney, resulting in a better draft and more efficient combustion. Direct transmission to the driving wheels also reduced energy loss. These elements became standard in later steam locomotives. The rocket achieved a maximum speed of about 45 to 50 kilometers per hour and had a mass of approximately 4.3 tons, using coal as fuel. Its 022 axle arrangement was revolutionary for the 1820s. The rocket was the winner of the Rainhill Trials and set the design template for future steam railways. It proved that steam power was safe, efficient, and profitable, inaugurating the era of modern rail transport. Coal formed millions of years ago from plant remains in ancient swamps and forests through processes of pressure and heat. Its carbon content increases with depth and age. Coal became an essential fuel for steam engines and industry. In the 18th and 19th centuries, coal extraction evolved from manual surface and underground mining to the use of mechanical hammers, steam pumps for dewatering mines, and early mining railways for coal transport. This led to greater accessibility and lower raw material costs. Coal processing involves sorting by quality and calorific value, drying, and sometimes pre-agglomeration into coke. Coke is a crucial fuel for metallurgy and heavy industry. Steam locomotives and industrial machines required high-quality coal with high calorific value. Comparing the calorific value, lignite yields 12 to 20 megajoules per kilogram, bituminous coal 24 to 30 megajoules per kilogram, and crude oil 42 to 46 megajoules per kilogram. Despite its lower calorific value than oil, coal was cheaper and more readily available in the 19th century. Major coal mining centers in the 19th century included Great Britain, Germany, the US, France, and Belgium. These regions fueled the development of steam railways and factory industries worldwide. Coal was essential for locomotives due to its high calorific value, which produced powerful steam, ease of transport and storage, and wide availability across Europe and America in the 19th century. Without coal, locomotives could not function efficiently. Steam locomotives enabled the rapid transport of coal from mines to cities and factories. Dedicated coal transport railway lines soon appeared, creating an efficient link between mines, steel mills, and ports. This increased the pace of industry and raw material availability. Steam locomotives were pivotal to the Industrial Revolution, providing a stable energy source and accelerating trade and urbanization. The combination of coal and steam propelled modern industry. Locomotives were catalysts for 19th century economic transformation. The challenging terrain of the Harz Mountains, with its steep slopes and narrow valleys, demanded special technical solutions for railway construction and locomotive adaptation. Tight curves and limited space presented a significant challenge for laying the track. Technical adaptations included narrow-gauge locomotives, reinforced boilers and brakes, and special cogwheel systems like the abur system for better traction on steep slopes. This ensured the safety and stability of goods and passenger transport in mountain conditions. The narrow-gauge railway network in Harz spans over 140 kilometers. Steam locomotives have been in use from the 19th century to the present, serving both freight and tourism. Harzer Schmalsperbahnen is a living museum of steam railway transport. Harzer Schmalspur operates over 140 kilometers of track, making it one of Germany's longest narrow-gauge networks. It serves major tourist destinations like Brocken, connecting all parts of the Harz region. The Brocken Railway, which reaches the summit of Brocken at 1,142 meters, is a prominent part of the HSB network. Its route is characterized by steep inclines and often challenging weather conditions. The Selketal Railway is the oldest section of the HSB network. It runs through the scenic Selke Valley, connecting Quedlinburg with the main line, offering picturesque views and historical significance. The Harz narrow-gauge railways are a major tourist attraction, providing a unique historical experience. Visitors can enjoy the stunning mountain scenery and the nostalgic journey powered by steam. The HSB network's main technical challenge is maintaining the narrow-gauge railway in challenging terrain. The use of specialized steam locomotives and regular infrastructure maintenance ensures operational stability. The unique heritage of the HSB is protected by the Harz Narrow Gauge Railway Association, which aims to preserve the steam locomotives and the railway infrastructure as a national historical monument. We have explored the historical importance, technical adaptations, and cultural heritage of steam locomotives in Harz. The HSB system continues to inspire engineers and enthusiasts worldwide.